Thanks so much for having me, and thanks to all the sponsors who make PyCon possible. I was telling a friend of mine that I've been teaching Python and to high schoolers, and some of my students have done some work in Flask or published web apps to AWS. He looks at me and says, "How did you get them to be interested in this? This sounds like magic. Are you a magician?" And so I've been thinking about that a lot, whether I'm a magician or not. And my answer so far, in fact, is that I'm not a magician. Because I think one of the problems with our industry, haven't even introduced myself and yet already telling us a problem, I think software is too magical, right? We have these phones, we wave our fingers over them. I'm told that you can summon a pizza if you wave your fingers the right way. You can summon a car to give you a ride. You can see moving pictures of your friends and family. So this sounds like magic, and my philosophical issue with that is if students think software is magic, that's not something that they feel they can immediately get involved with. It has secrets and tricks with it. All this is to say, I'm therefore anti-magic, and my new title is anti-magician. Please indulge me in that. We're gonna do 3 things today. We're gonna talk about the curriculum that I've been teaching in Boston, and this so far is a personal project, but the purpose of being here today is to blow it out as open source and say, let's all get involved in making this curriculum as good as possible and see what we can do with this. I know that this is being taped as well, so hello, people in the far future watching this video. Regardless of your background with Python, I think you'll find something interesting here. If you have a lot of Python background and you're interested in figuring out what makes good curriculum, I'll speak to that. And if you have less Python background, but you want to know why are certain things counterintuitive, we're going to speak to that as well. In the third half of the show, we will be doing a discussion of how to assess students. Okay, car talk reference. Am I getting no laughs on this? Come on, people. Come on, please. Okay, it's fine. I don't mind. If my jokes fall flat, that's going to just be what it is. So I'm just going to embrace that, actually. I'm a web developer. I'm based in Boston, and my background is in aerospace engineering. I worked in robotic aircraft, path planning, and also worked on jet engines. So what this means is that if you know how to multiply, I can teach you how a jet engine works. And I think the extreme gift of that, of this varied background of mine, is that it makes me a very passionate Python teacher person, because I know what it is to have power in the full stack and why that might be significant. So my work truly has come out of a question: what does it mean to have literacy in the technology sector? And I mean that very broadly. I know we're a lot of software engineers here today, so I'll speak to the software engineering condition. But yeah, what if we ask the question, all right, we have access to students outside of school at public libraries. I didn't fill you in, but that's where this teaching is happening. I'm offering one-off workshops for free to students. So what does it mean to try to give them some literacy in Python? And I think what you'll see in the slides, and what it's important for me to be transparent up front, I'm a lot less interested in having folks walk in the room and memorize syntax than I am in having them walk in the room and get some of the habits of real engineers. So my practice is just to speak to the students as if they're engineers already, much as I'm doing with you now, because I think if I assume from the get-go that they're just already engineers, I can increase the chances that they'll walk out of there thinking of themselves as people who can study this, use this in a career setting, and help us solve some of the problems that face us as a society. Inspirational intro of talk complete. So again, drawing on my own background and my own interests, I thought, if I want people to be literate in technology, let's talk about people who know a lot about technology. Astronauts and the people who help them have jobs. Not really an issue in society, employment of astronauts. All right, so one of the challenges that I give the students, I present them with 2 essays written about astronauts. Astronauts, does anyone not love astronauts? Let's have a I love astronauts show of hands. Just indulge me on this, thank you, good, thank you. I wanted to be an astronaut when I was a kid, anybody else? Okay, a couple, good, okay, great. Stay with it, stay with the dream. So I give them these short essays and ask them, how would you have the computer grade this? So I hope, I know it's always hard to tell a story from the middle of the story, but right here we're already signaling to the kids sorry, the young people, the future engineers. We're signaling to them, hey, if you're new to Python, no worries, we'll help you write a filter to look for some informal words in this essay. But if you're an old hand at Python, maybe you could bust out some natural language processing and start making some criteria for what makes strong writing. And that tends to be a challenge that keeps people busy all afternoon. I will now read you part of this essay. Peggy es ingeniera y tiene mucha experiencia en vuelos espaciales. En este viaje a la estación espacial rompió el récord mundial porque estuvo en el espacio durante más de 9 meses. Can you imagine? I can. It is incredibly hard to live in space for a long time. She is a champion of outer space. I like champions. My PE teacher in the 3rd grade said, we are all champions. Heartbreaking. Okay, we're going to use a lot of dry humor here. So this is one of the essays that the students are asked to analyze and evaluate. I give it to them on paper in addition to through a GitHub repo that I'll link you to in the slides here. And I say, what would you do with this? So I'm going to summarize some of the syntax, sure, but under my pedagogy that we're less focused on syntax and more focused on empowerment, I want to just cue you on kind of how we pull this trick. There's a lot of slides here, and we're going to post them so you can look at them later in detail to see what skills we're going for. These 2 skills in particular tend to be pretty tricky to get somebody who just walks in off the street to learn automagically. Again, going to give you some tricks for that, but we really skew it toward this. What if this is my 2 hours with this student, and I will never see this student again? What are they going to walk out with? A little bit more of understanding of these 2 things, and if they're already advanced, fine. Talk to them about how to access the Google API. I'm going to take questions at the end, by the way, so save them up. We have a big focus on having people start in the shell. And, well, I didn't even realize I used the word magic here by accident. So I think without the shell, there's this kind of sense of powerlessness. But if people have access to the shell right away, and they get to see things right away. So I give this to them on paper and ask them to type it in the shell. If you mistype something, you get a really groovy error. So that's free learning right away. Errors are the best thing ever. And if you type it properly, you might get to see the word true. So again, our concern is not to get into discussing data types right now and the word Boolean. It's fine. Let's just see the word true, and let's see how we could start using this to write code to solve this problem. One nuance to share automatically is something is very counterintuitive to students coming from math class. So in math class, we say the right-hand side of an equation is the same as the left side if there's an equal sign in there. You can move them around. Right-hand side equals left-hand side equals right-hand side. Not so in Python. So we really belabor the point. Right-hand side, information or data. Left-hand side, place to put that data. I find if you do that up front and really disambiguate the use of equal signs and assignment in Python, we can accelerate how quickly students are actually able to use even advanced data structures. So flagging this as item number 1, tweet about it. Again, instead of really looking at discussing the nuances of typecasting, we're just giving them stuff on paper. Go, write this in the shell. They come and ask me, like, how do I do this? I'm like, I don't know, go type in the shell, see what's up. You can tell I'm from New England. This is this very New England thing to do. We really just want them to explore in the shell. I have 2 more counterintuitive things. Again, these are going to be online, so I appreciate that I'm blitzing here. We found that it's critical to be careful about the variables that are being used in a for loop. So the structure of this workshop is to give some introductory material in a lecture format. And I've already said we're really hammering on how assignment works. We're also hammering on which variables you get to choose and which are reserved words. Yes, syntax highlighting, but very important to empower the student to be able to do this on their own. So if we use X in both of these cases instead of B, I don't know if you can see the mouse. Here's B. If we use X in both cases, the students sort of think that X is something they have to use all the time. So we switch that up a little bit, again, trying to empower them to control exactly what the computer is doing. You get to choose what the computer says to you. So let's say which loop we're doing. And then this, one of the most self-satisfying things to do is write clever Python code that reads like a sentence for word in words. Has anyone ever chuckled to themselves after writing really clever Python code? I don't mind saying I'm the only one that does that. Yes, thank you. So for word in words, you write this, you're like coding late at night, chuckle, I'm so self-satisfied. And the problem for students is that, again, they're looking for patterns. They're looking for things they can grab onto and learn about. And this looks almost like maybe Python is fixing this for us. Maybe we just sometimes put an S and sometimes don't put an S, and Python comes in and saves the day. So I had to train myself not to do these very nuanced variable namings. Just stick with single letters when we're really trying to emphasize what a variable is right at the beginning of time. So the structure for this, as I mentioned, we give a 20-minute introductory lecture, followed by a 5-minute challenge the hotshots. Give them something to chew on. What could you work on in this problem? Well, pop quiz. You could try to figure out if either of these essays had been plagiarized. Let's just say from the open internet. And again, whether someone's going to use natural language processing or just something they cook up out of their own mind. We do have folks show up, 12-year-olds with scikit-learn, the children of data science PhDs. And we got to give them something to work with too. Again, the slides are going to be online. They're going to be, in fact, you can get part of the information here. So we have a repo already with this particular problem in great detail. So if you came here to get something you could just take and run away with, here it is for you. The master branch is the one aimed at students, which contains some code snippets and loads those essays. It does a CSV reader for them so that they can just have things in variables as lists of words, essays as lists of words. And then there's this branch, teaching resources. So I'll give you a second if you need to take a snapshot. Teaching resources branch also contains these PDFs that are very detailed worksheets that show the code I indicated up here for the work in the shell, and also some other stuff. I built an app to test mental math skills. And the purpose of the app was actually then to turn around and just give the data back to the students. So consistent with the idea that I'm treating them as engineers, I'm saying, hey, if I were to give you data about how someone does with multiplication skills, and I'm from the US where we have very low math literacy, so it's not hard to get really diverse data in multiplication skills. And I'm heartbreakingly good at math, so it is really sad for me when we have multiplication skills that don't work out. But I think this problem has shown students that they can just dig into a data set and get going with it, again, regardless of their background. Yes, there is a nested dictionary in here, but we can pull that out and give it to them individually in a variable if they're very new to dictionaries. And I just ask them, I ask students ranging from age 11, what if you had this data? And this is one little piece of data from one user, from one session, practicing their multiplication. First of all, what do we know about it? They tried it one time, they spent 2 seconds, so I'm just looking at this nested dictionary now that's under the key session data. And they got it right 0 times. So we'll see if I'm speaking way too fast or too slow. How many people right here, right now would say this person has mastery of the multiplication problem 4 times 8? And who, raise your hand if you think they probably need a little help. All right, I think I'm probably talking way too fast. So they attempted the problem 1 time. It took them 2 seconds, and they missed it. So the students are the same. They're very hesitant to raise their hands, right? They're like, did I just understand that? I'm seeing a data structure I've never seen. But again, we're coaching them on just jump in and start messing with this data. I give it to them in 2 formats. I will post this as well. But I give it to them in Python format as just a list of dictionaries, a very small subsample, and then I also give them a MongoDB file they can just ingest immediately with MongoDB if they want more data. This is a snapshot of what one of the worksheets looks like. It says, come find us. Even if you're the only one running a workshop, it's nice when the kind of quiet, nerdly people come up to you and just sort of voluntarily tell you whether they understand or not, and this is a trick for getting that to happen, since, I don't know if you've experienced this, sometimes engineering people are not always just really open communicators. So we're doing that. And I have a million stories to tell here. This is so great. Again, working in the shell and helping people figure out what's a dictionary and how do we deal with it. And we try to use as many examples from different industries and different walks of life to get people to see themselves in the curriculum. So again, I'll pick on the US. We have an issue with Islamophobia in the US that we're trying to work through. We're trying to get the US to understand that all people are indeed created equal. So we do try to go out of our way to just use lots of examples, people from different places in the world. This is still profound to me. I'm still really into math. Awesome. Good. Counterintuitive thing number 855. So if we give them a dictionary that contains, again, just to recap, this is information about how someone does with multiplication. How many times did they try and what was up? So if I give them this and I'm trying to coach them on how to get information out of the dictionary, so I'm secretly hoping, I know this is not so secret now that I'm announcing it into this microphone, I'm secretly hoping they will write the name of the dictionary, followed by a square bracket, followed by the name of the key. I will be moved to tears if they do this of their own volition. And instead, what they do is they look right there in the key called attempt, they see it's 1, and so they just write that it's 1. And at first, I'm like crying quietly in the corner, like, I was so ambitious, I was going to teach dictionaries. And then I realized that, again, students just want to cut to the chase. A student who does this second case, they're off to the races. They can still run their algorithm. They can still use the Python file that has the list of dictionaries and really come up to speed and write an algorithm to figure out which math problems are the hardest. So they'll have plenty of time to figure out the syntax of dictionaries. Again, the take home is just get rolling. Just write your algorithm. We'll translate it into Python with you. But I had to learn this since the engineer in me wanted to see that syntax right away. Same thing, just another example. We want them to write flexible code, but flexible code doesn't matter if your code is 20 lines long. And we do the same format for this math data problem. And actually, serendipitously, I'm taking a page out of Camille's book, the keynote this morning. Just as I thought about what would be most meaningful to capture for you, and I got some feedback from engineers in Boston. So big shout out to the Boston Python users group for reviewing this talk and helping me figure out what would be most useful to hear. I'm free of the typical assessment criteria in schools. I don't have to prepare someone to take a test that their teacher signed them up for or that their parent guardian thought was really important. In some cases, those tests can be important. I actually can assess them for criteria I would assess an engineer that I might hire. So I call this practices of an effective problem solver, but it could equally be called practices of an effective professional engineer. And I want to tell you how we're measuring this, since one of the best ways to make curriculum is to think about how you'll measure the reaction or the ability afterwards. I'm just going to walk through these. So the first one is, can somebody inquire with curiosity? And let me win you back. If you're sitting in the audience and you're thinking, the talk had some really great code, came here to see lots of syntax, getting kind of soft now, maybe we'll take a water break, lunch is happening. I'll remind you that reading technical documentation is a critical stage gate for being able to write open source code, write your own documentation, really use the power of a tool that you might have only been using part of, if you can just jump into something. So let's review these slides with that bias. We're trying to inculcate in students extremely technical skills, which I happen to be phrasing it with words instead of syntax, but that's where we're driving the boat. So how do we get somebody to just sit down at the shell and rampage, just write things? I've seen this as a deciding factor in whether somebody is able to sink their teeth into Python or just kind of came on a field trip to see this workshop and thinks of themselves as an outsider to the engineering industry. This is the shell. Behold. It's from a student that I taught on Thursday. Clearly, I made my slides weeks ago. I would never edit them the Thursday before the conference ever. But I just couldn't resist. This was so beautiful. And we're trying to get the students to think about different types of data. Specifically, how do you get input from the user? What do you do with this input? If you're trying to do either math, or maybe you're trying to move a character, a sprite on the screen, which, by the way, you can do with Python Turtle. You can spawn sprites and move them around the screen using turtle.clone. Talk to me about it. So how would we get them to understand that input puts quotes around something, given that we're in a universe where Students don't just walk around saying the word typecasting to each other if they haven't ever been in a computer science class. So the way I do it is, again, with the New England, the Boston leaning here, I do not tell them what typecasting is. I just give them a little bit of code and tell them to mess around in the shell. And the reason this represents really high achievement on that first metric, the inquires with curiosity, look at what this kid did. Sorry, this young engineer, this future person, this future leaders, okay, great. They started with using str to typecast the number 25. And my question was, how would you get this back into a number so that you can add it together with itself and get 50? Try that in the shell. Okay, so first he tries just adding it. He gets 2525. Again, I don't care if you learn the word concatenation. Don't care. 2525 apparently is not 50. So he continues on this rampage of curiosity. All right, maybe I'll use str again. Maybe it like reverses itself or something, which I think it's just fabulous. This is one of the hardest things to teach, which is why I'm raving about it. Typically the students just, if they're new, they sit at the shell. And they just think, as if by thinking, they will somehow see into the internals of the computer. This is lost on me. You just got to type at the shell. So then maybe he assumed that the plus operator is just somehow broken. Try the multiplication operator, and let's try typecasting it again. So I think this is gorgeous, like far and away the most beautiful thing that happened this week. Yes, I am a nerd's nerd. And it was followed by this equally gorgeous thing where I gave a hint. I said, what if you use this int situation? And then he got this error, which again, we are just celebrating errors from now until the end of time. I tell them, this is the computer speaking directly to you. And to me, as someone who had a lot of professional engineer mentors early on, I wanted to pause and talk about the significance of this again. Even though it looks like it's just this little thing that happened in the shell, I often am the first adult who has spoken to these students as if their technical ideas really matter. Many of them, as I said, don't have an engineer at home. They don't have access to technical curriculum at school. And for me to give them the power, again, this is on my best day, if I do this well, I want them to have a sense that they control what the computer says. It's not a magical piece of glass in their hand. It's something where the computer speaks directly to them and they get to control it. When I was 10 years old, right, a quick story, my dad got out an HP calculator that he had used in engineering school, and he said, hey, Robyn, did you know that with this calculator, I can calculate the trajectory of the lunar landing module? And I was 10. I didn't know any of those words, like what's a module, what's a landing, and what's a lunar? But he was clearly very, very excited. And he just started doing it. He starts talking about projectile motion and more words I don't know, the thrusters and just everything, the initial velocity. And he goes off and he calculates this. I think it took an hour. I went and played basketball and had a snack. I came back, he was still doing it. But the advantage to me is there was this full-grown adult not slowing down, not dumbing anything down, not sitting there to explain what a module is, just like making the trajectory of this spacecraft. Lo and behold, I become an aerospace engineer later, but I think that's again what we're trying to do in these workshops, which I think differentiates this curriculum and which is why I'm doing a call to action for all of us here. Yes, there are many, many groups writing really fabulous curriculum, but I think we still have an extraordinary shortage of compelling problems that students can sink their teeth into and feel empowered and get access to. So, getting down off of soapbox now, returning to slides. If you were alive in the 60s, you know this quote. Dr. King said that faith is taking the first step even if you can't see the top of the staircase. And I dwell on this for the same reason that I think Camille gave her talk this morning. We're really looking for people who can just jump into technical problems, break them down into smaller pieces. So I'm going to show a few more of these criteria. We want the students to do the math. This is a problem that we often give, which helps show just how much exposure someone has had and how much coaching they might need in order to, again, feel that they control the machine. They can figure out how many things something happens, maybe by using the print statement if they're confused about a loop, or just we're trying to give tools. So how many houses are there in this list? Feel free to call it out. there are 5 houses in the list. But why is 14 minus 10 only 4? And so we ask that, and we're really concerned with teaching the students this. I will be the first to admit that you can use for I in range length of list and not give it a second thought. Oh, cool, range length of list, it'll go through my list. However, if the student begins understanding loops from the standpoint that I might have to count this, it might be convenient if I knew how many times my list was going to run. If we start them from that standpoint, we're finding that, again, they're just more empowered in writing code and thinking about it. So here's another, how many offices? This is something we would specifically like some help with. How fast do you think you can teach this to different ages? Do you have examples? Do you want to write some sample code? I do. Talk to me after. Same issue with this one, of course. 100 minus 10 is only 90. And I'm going to quote some of the geniuses of our industry, although all geniuses in our industry are way too humble to just call themselves geniuses. One of our keynotes today, Julia Evans, has, of course, done amazing technical things, but it's not lost on me that she has gone out of her way to also talk about how she empowers herself to study those things. So I'm going to do a quick quote of her and of another engineer. In one of her webcomics, she wrote something like, I'm not even sure what, they were trying to discover a very complicated problem, but one of the little comic characters says to the other, oh, this is not so hard after all, we can do it. I'm obsessed with this, because when students gain this skill, then again, they're off to the races. They're reading documentation, they're taking a chance to write difficult functions, they're penciling in functions and maybe writing pass, they're just fleshing out their code. So I indeed am going to give you a few examples of what self-talk is like. And I don't mind admitting that I do this all the time. If I'm working on a tough thing, sometimes I even speak like, who's that politician that used to do this? Bob Dole? Speak in the third person about yourself? I don't mind admitting this. So here are some things that you can say. Again, I want to empower you with this so that you are uninhibited about telling students that they should do this. Because I've taken so many computer science classes, I took them at MIT, no one ever talked about self-talk. But if you ran a team of world-class athletes, you better believe this would be part of the curriculum. Thanks for putting up with my preaching on this, by the way. It feels so preachy. Yeah, we want these to be tangible in order to be really effective, things that can help a student in the heat of battle, when they're really feeling down. And the final thing we're trying to engender that we must therefore measure is, how does somebody interact with open source? Is this someone who is coming up in the ranks, who's going to be writing open source code? Because I'm in charge, so that's what I want them to be. That's what I want the world to be. So the metrics here are just, what do? Do they give back? Do they think this way in class? Are they willing to import code they've never seen and just try messing with it? And if they find something wrong in an open source project, do they then submit a pull request? How does it work? So the idea I want to leave us with before I take questions, I started with the thought of what is literacy? And I want to close with the thought, what is fluency? Because again, I think that if folks are to see themselves as possible technologists ever in the future, whether that means coding for an hour a day or 2 hours a week writing a script to pull something down from the internet, if they're to see themselves that way, they need a level of fluency that it's currently hard to get unless you have this sort of magical access to someone who can mentor you. But what I propose is that if we write a bunch of curriculum, that means all of us. I think as Python, we can actually write the best. I know I'm supposed to be modeling humility for my students, but I think that as the open source community, we can outrun a lot of other efforts and develop curriculum that will help people articulate their thoughts and articulate their own technical solutions. And I hope that through that, we'll get people who previously felt as if they're just passive consumers of software, we'll get them to feel that they can also speak and they can also have a voice. Thank you. And I'm going to take a few questions. really enthusiastically, I will take these questions.
Just kind of high level, do you mind explaining the background you think of the students themselves and how you started this project?
Yes, sure. The background of the project. I think it was really seeing that, again, there are nonprofits all over the place, especially in the US, that develop curriculum, but multiple friends of mine had come to me who had school-age kids and said, hey, we know you've been teaching, crazy amounts of math and et cetera on the side. Could you help our students? They've run out of curriculum at school, or school has no curriculum. So that's how it began. Yes? I have not yet seen the new GitHub thing, but I'll check that out. Thank you. Yes?
Hello. Yeah, thank you for your talk. It's awesome. Coming from a third world country like Colombia, like I am, I was thinking, how have you ever tried to apply the same teaching methodology to adults that didn't get any advantage when they were kids? Have you ever tried that? How does it work?
Great question. Yes, I'd ultimately like to be age agnostic. So we're just going to put up as many repos as we can and help people find their way within the curriculum. I think that bottom line of empowering people to feel that, I don't care if you don't know any syntax or you've never coded. You have a brain. You could write instructions, and you could write them in whatever your native language is. So if you could write instructions, that's what a computer lives on. We'll put the instructions in Python. So I think that thesis, I think, will carry over to adults. Any more questions? Yes? Cool. So the question is, how do we keep students motivated who are intimidated by the curriculum or by Python? I do two things, and it really just comes straight out of the coaching playbook. So I play a lot of sports, so I'm really into just how you motivate athletes. I think that's where all the secret sauce is of how people become self-aware, and not to mention work in teams. So first, for the astronauts problem, I tell them, hey, this would be really fair game for a Google interview question. And so if a kid is in there judging themselves really harshly, I can't do this, and I say, this would be fair game to interview an adult who has at least one computer science degree or who possibly has many years of experience. I'm trying to show that there's a spectrum, and I also really play up the point that these are unusual problems they might not see in school. And so sure, there's a skill of learning programming, but then there's this other skill of learning how to think about problems. So by doing that, we're really trying to give permission, or in the kind of leadership language or pedagogy language, make a safe space for any range of so-called performance. We're really just trying to take out any performance metric that's related to memorization. We're just trying to take out. Did that answer a bit? Cool. Because it's not lost on me. Again, all that self-talk of what if you want to learn how to play ice hockey, right? We're here in an ice hockey country, right? But you've never put skates on. What do you tell a student in that moment? Okay, now you can't skate. But there's all these people who've learned to skate. They're not smarter than you. They just put the skates on and held onto the wall. And eventually you hold on the wall less tight. I'm ready to coach a hockey team right now. Try me out.